Look at the cracks, this whole section could go. It's worse than I imagined. The rust is everywhere. Watch your step. The deck is giving way. Before we touch anything, we have to assess every single foundation stone down here. If the base is compromised, nothing above it is safe. Structural assessment is always the first step. Always. The cables are completely shot, fraying everywhere, wrapped in vines. I'm photographing the worst sections now. The rust is unbelievable. Noted, the scale of this is just overwhelming. Watch your step. The floor is unstable here. I see it. I'm going to document this section. Good idea. Be careful. Look at how far the deterioration goes, from the foundation stones below the waterline all the way up to the roof. A complete structural inspection means every single layer, every single level. You cannot skip a single section. Clear the base. Watch for rebar. Got it. Moving this pile now. Swing it left. Dump in the truck. This glass is sharp. Keep back. Good haul. One more scoop. Without a clean, safe path to bring in machinery and materials, we literally cannot do anything else on this project. Every restoration starts with access. This pile is going up fast now. Good, let's get this next bit in. Sorting your debris isn't just about being organized. It lets you separate what can be recycled, what can be reused, and what has to go to landfill. It saves time and money in the long run. High pressure washing is the first real cleaning step on a stone facade like this. You have to be careful with the pressure settings. Too high and you can damage the stone itself, which is already fragile from years of neglect. When a stone is beyond repair, cracked counterroy roads have been made TP has to be confirmed of the new command will fail. Metalwork on this bridge is the iconic blue framework you see in every photograph. Before any paint can go back on, every millimeter of rust has to grow and destroy the structure from inside. Rust converter transforms the iron oxide, the rust, into a stable compound that actually forms a better base for the primer. On a structure this size with this much rust, it's an essential step. This blue is already making a huge difference. It really pops against the rust. Keep it steady. Will do. Let's get this whole section done. This section is completely compromised. Yeah, testing this beam now. Documenting, watch your step. Moving to the next area, be careful. Every piece of rotten timber has to come out. You cannot build a new roof structure on rotten wood. The structural integrity of the whole roof depends on everything being sound, right down to the base. The new roof structure has to respect the original design profile of the tower. We're matching the original pitch and form exactly, but with new treated timber that give mole last for generations. Exactly, this will hold strong. Okay, unrolling now. Watch the edge. Got it, stapling as you go. Wind's picking up, hold it steady. Okay, securing it now. Good. Keep the tension. Traditional slate roofing on a structure like this is non-negotiable. It's the only material that matches the original character and the only one with the longevity this building deserves. Correctly laid slate can last 200 years. This piece needs to be dressed perfectly into the step. Got it. I'll get the mortar ready. Good. Make sure it's fully bedded in. Tapping it in now. Looks solid. This section feels soft. We need to reinforce it. The railing is fractured. It needs a full replacement. Look at these holes. We have to Sean is unstable. Everything that's failed has to come off before anything new goes down. The floor structure underneath needs to be fully inspected once it's clear. We need to know the steel frame itself is still structurally sound before we put any new floor on it. The new walkway floor needs to be non-slip, weatherproof, and structurally certified. Steel grating at this stage gives us a strong, safe working platform that's appropriate for this bridge environment while the rest of the restoration continues. Before any physical clearance work can begin safely inside this tower, we need adequate lighting and ventilation. Working in the dark or in dust-filled air is a serious safety risk. Preparation is everything. Debris chutes are the safe way to get rubble from height down to the skips below. You never drop material from elevation without a controlled chute. It's a serious safety hazard to anyone below. All the old services, pipes, conduit, everything need to come out completely before the walls can be cleaned and prepared for what comes next. None of this old infrastructure is salvageable or safe. This is the moment that makes all the brutal clearance work worth it, standing inside the empty shell of one of the most iconic structures in the world, seeing the raw space for what it really is. This is where the real transformation begins. Before a single cable or pipe goes into this building, every single service route has to be planned and marked out precisely on the walls. Every electrical cable in this building will run inside conduit. This is the correct way in a structure like this. Allows future replacement without breaking walls, and it's essential for compliance with building regulations. We're installing separate circuits for lighting, power outlets, the kitchen, the bathrooms, and the mechanical systems. Every circuit needs its own correctly rated single it's complex. It's coming through. All the water supply piping needs to go in before the internal walls are built. Once walls are up, you cannot access these spaces. The sequence of installation is absolutely critical in a project like this. In the areas that don't conflict with the structure or the other services. Fiber optic requires completely different handling from electrical cable. It's glass inside that shell, and if you kink it or bend it too tightly, you break the transmission path. This is the backbone of the entire smart home and security system. All electrical circuits must be fully tested before any walls are closed up. In-seam resistance, after the walls are plastered, you have to open them up again. Testing at this stage is not optional. Every service run hidden in these walls is documented. We have full as-built drawings showing exactly where every cable and pipe is in every wall, so that nobody ever drills or cuts into them accidentally in the future. These steel beams are the skeleton of the new internal floors we're building inside the tower. They span a width of the stone walls. The load goes to the original stub beams cut into the stone walls. These beam pockets have to be exactly the right size and at precisely the right height. If the beam pocket is wrong, the floor level will be wrong for the entire floor. Precision here affects everything that follows. The concrete slab alone is strong in compression. It can carry loads pressing down on it. But without the steel mesh tensile stride, it has virtually no crack fair under real roasting. The steel... Keep it steady, I'm spreading as fast as I can. Got it. Moving to the next section now. Looking good, almost there. The floor finish at this stage determines the quality of whatever floor covering goes on top later. A badly finished slab with hollows every floor covering on top will show. You only get one chance to finish concrete correctly. Building multiple new floors inside an existing historic tower structure is one of the most complex engineering challenges in restoration work. Every floor level has to be structurally independent enough to perform correct stage. The partition layout defines every room in the mansion. We're showing the visual connection to the stone walls and the views outside. We're using moisture-resistant board in the bathroom zones and standard board elsewhere. You have to match the board specification to the environment it will be in, or the walls will fail over time. Before we remove a single stone from this load-bearing wall, the temporary propping system must be in place, checked, and signed off by the structural engineer. This is non-negotiable. Removing stone from a load-bearing wall without propping is an immediate structural collapse risk. This steel lintel carries the full weight of all the stonework above this opening. It has the right steel grade. This is the element that makes the enlarged opening permanently safe. Triple glazing in a building this exposed to the elements, river wind, it gives us thermal assurance, acoustic insulation from the river environment, and the structural safety the opening requires. Good plastering is one of the most skilled trades in construction. The speed of application, the timing of the finishing passes, the consistency of the mix, it all determines whether you end up with flat, neat hollows on. In a luxury bathroom, the tile installation quality makes or breaks the final appearance. Any deviation is immediately visible on a large tile. There's nowhere to hide imperfections. Every base cabinet has to be perfectly level. The base will not sit correctly, will not hang correctly, and drawers will not slide properly. Leveling is painstaking but absolutely critical to the final quality. Wide plank engineered hardwood is the correct choice for a floor over a concrete slab. It's dimensionally stable enough to handle the temperature and humidity variations in a space like this. Will not expand and contract too much and cut or gap. Creating a new balcony opening in a load-bearing historic stone wall at this height is one of the most complex engineering interventions in this entire project. The structural calculations, the structural engineer. The propping system transfers the load that the wall is currently carrying down to the floor, bypassing the section we're going to open. Until the new permanent steel structure is in place and cured, these never be all ducts. Every stone we remove goes into controlled storage. These are historic stones from Tower Bridge. Some will be used for the reveals of the new opening, some reused elsewhere. Nothing from this building goes to waste if it can be avoided. This steel frame is the permanent structure that makes the balcony opening safe forever. It has to be set exactly level and plumb. It defines the level of the balcony floor, the line of the door frame, everything that comes after. Looks good. Tightening. A cantilever balcony is one of the most structurally efficient and elegant solutions. The balcony deck is supported only from the building with no columns below. Composite decking for an exterior balcony on a building this exposed, on a river, with full weather exposed to won't the wastelands, and it will look the same in. Every fixing in this balustrade is a safety critical structural element. These fixings are holding the glass against the load of someone leaning on it at height. Every single bolt is specified, installed to the correct torque. There is zero margin for error at this height. Lifting now, guide the bottom edge. Got it. Lowering into the channel. It's seated, go ahead and clip it. Clipping now. All secure. Wow, look at that view. Okay, ready? Lift on 3. 3, keep it level. It's in, test the slide. Smooth as butter. This hardwood will bring the elegance this space deserves. The walls must be perfectly smooth before we even think about the lights. These lights are designed to highlight the unique architecture of this bridge. Looks perfect up there. Let's test the connections now. Ready when you are. Luxury starts with the smallest details in these bathrooms. Definitely. These gold fixtures are coming along nicely. This tower will become the ultimate private cinema room. A complete gym here will have the best view in London. Yeah, let's keep going. This spot is perfect. It will be. We are turning this walkway into a climate-controlled private gallery. This library will be the quietest place on the entire bridge. This entertainment hall will host the most exclusive parties.